So, how did that poll look? That poll looked pretty good. It was pretty good. 18 was difficult. 21 was kind of hard. You still think it's too much. I don't think it's quite enough. I mean, if you took out 18, how was it? Doable? Less doable? You're not saying anything today. Okay, it's fine. It's all good. Has everybody gotten a calculator, or they're in the process of getting one? Okay, any silence I'm going to assume as whatever I want it to be. So, yeah, it is. Okay, good. Yeah. Anybody have corrections they want to hand in to me? Any corrections? If you do, just make sure you get them to me. They have to. No, sit down. Not right now, but just make sure you get them to me by the end of class. So, I'm seeing a lot of votes for 18. 18, is that what I saw? 18. I would imagine you guys could do about half of this question, but not the other half. Right? Or am I wrong here? You can do it. You can find the equation of a line pretty confidently. You're pretty good at that. So you have 2 points. You have 2, 2, and negative 1, 0. You need the equation of the line that passes through those 2 points. What do you usually find first? Slope. So the slope is going to be 0 minus 2 over negative 1 minus what? Negative 2. So it's going to be negative 2 over 1, which is negative 2. Careful with those minus signs. Careful with those minus signs. We now have a slope. I like that point a little better. This is the equation you should use all the time. Y minus y1 equals m times x minus x1. And in this case, I'm going to focus on that point right there. Does it matter which point I use? No, it does not. Y minus 2 is equal to negative 2 times x minus negative 2. So you end up with y minus 2 is equal to negative 2 times x plus 2. You could stop there, or that's in point-slope form. You could write it in slope-intercept form if you really want to. I know you guys feel a lot better when you do, so okay. Y minus 2 is equal to negative 2x minus 4, so y is equal to minus 2. What's the domain of that function in terms of this question here? It's the line segment from negative 2 to negative 2, 2 to negative 1, 0. What's the domain of this segment? Yeah, I'm piecing it together. Equal and less than or equal to negative 1. Exactly. So far we can write this as f of x is equal to negative 2x minus 2 for this part of the domain. And with that, record. Okay, so that's that one segment. But now what's the second segment? Did you draw this? The top half of the circle with center of the origin and radius 1. Did you draw this at least? If you ever get lost, draw a picture. So you have the point negative 2, 2, negative 2, 2, and negative 1, 0. So this is the first segment we just did right there. Top half of the circle with the center of the origin and radius 1, it's going to look like this. Do you know how to find the equation of a circle? If not, did you try to find it? You tried to find it? Where'd you look? You can plug stuff in your calculator. Guys, if you're totally lost, you have a textbook that has this in it and an infinite resource of information courtesy of your computer connected to this magical thing called all the information the human race has ever gathered in the history of the world. Get lost? Need an answer to something? You need to find the equation of a circle? You could go to Google and type in equation of a circle. I bet it'll deliver some pretty good results for you. The equation of a circle with radius 1 at the origin is this. Is that a function? No. It does not pass the... So the top half is one part of it, the bottom half is one function, the bottom half is another function. How do we go about separating it into the two functions? What do we have to do? Isolate y, yeah. So y squared, we did this before, I think. What do we do now? We can't, no, not substituting yet. We need to get, y isn't alone yet. It's there by itself. It's having an identity crisis, so we need to isolate it. So it's y is equal to what? And someone said it over there, positive or negative that. When you add in a square root, you have to do positive or negative. So you really have two functions here. You have y is equal to the square root of 1 minus x squared, and y is equal to negative square root of 1 minus x squared. One of them is the top half, one of them is the bottom half. How do you go about figuring out which one is which? Yeah, what's an easy point on the top one that's not on the bottom one?
0, 1.
Yeah, 0, 1. So when you plug in 0, you better get out 1. Which one is it? A or B? Yeah, when you plug in 0 into this, what do you get out? 1. When you plug in 0 into this, what do you get out? Negative 1. So it's definitely this one. So we plug in the square root of 1 minus x squared. What's the domain of this part of the function? Yeah, and you see these two pieces right here? Can they both be equal? Meaning, can I put an equal sign right there? No, because if I do, would it be a function? It wouldn't be a function. It would overlap at that point. So you have to choose either, everybody, either this, or what could you do? Strictly less than and less than or equal to. One or the other. If you do both, what happens? It's not a function. Generally, the equal sign on the first one doesn't really matter, though. If you wanted the bottom half, what would you do? Put a negative in front of it. So this right here is the top, and this right here is the bottom. Go to lunch. 85, yes. 85, number what? 1F. Oh, you can't do, excuse me, you can't do F. Skip it. Sorry. I didn't see that section.
Oh, okay. Oh, good, yeah.
Just so you know, 1 to 1 means strictly increasing, meaning it always increases or always decreases. Does that function always increase or always decrease? No, it's not 1 to 1. That's just a preview. Moving on. Any others? 5?
Yeah.
Seems like a good one to do. So to ask, find the domain and range of the function. Oh, we didn't do range in the other class, dang it. So we'll talk about the domain. Okay. The domain of a function. What is the domain of a function? Can someone actually tell me what the domain of a function is? Yes. All the possible x values. All the... Yeah, you're saying the same thing. The set of all... input values. So how do you go about finding the domain of a function? What set do you start with? What's the biggest domain possible? All real numbers. And then what do? You find out what x can't be. Exactly. So you start with all real numbers, and then you take away what x can't be. What are the two things we're watching out for? Square root of a negative. Yeah, exactly. So on this one, is there any division?
No.
So we don't need to watch out for that, but what about this? And it has to be an even root. And is that an even root? Is square root an even root? Yeah, there's an invisible number right here, actually. What is it? 2. So it's an even root. So we need to make sure what is true. We need to make sure what is true. That what. Let's use no pronouns. But what is. We just said out loud we don't want this to be negative, so therefore what has to be true on this function? 4 take away 3x squared has to be what? Has to be greater than 0, yeah. So we have to find that. When that's true, that's the domain of this function. How do we find out when it's greater than 0? What do we have to find first? Where it's equal to 0, yeah. So 4 minus 3x squared is equal to 0. So 4 is equal to 3x squared. So x squared is equal to 4 over 3. Take the square root of both sides, so x is equal to plus or minus the square root of, which is plus or minus the square root of 4 over 3, square root of 3. What's the square root of 4? Plus or minus 2 over... Does that look kind of familiar? It's a common what value? It's a common value you see in... Yeah, in unit and trig. Yeah. Usually you don't see the radical in the denominator. You usually want to rationalize the denominator. What do you multiply by to rationalize this denominator? Square root 3 over the square root of 3. So you end up with plus or minus 2 root 3 over 3. So you have this number line now. you have negative 2 root 3 over 3, and you have positive 2 root 3 over 3. This is the x value, and this is 4 minus 3x squared. Well, when you plug in this, you get out 0. When you plug in this, you get out 0. Are there any other values you can plug in for x to make this equation equal to 0? Are there any others? No, we found the only two. There are 2 of them. There are no others. We talked about this before. That means that everything to the left has to be either all... If none of them can be 0, all of those values to the left either have to be all positive or one or the other. Everything from here to here has to be all positive or negative, and everything from here to here has to be positive or negative. How do you figure out which regions are positive and which regions are negative? What do you do? It's pretty easy. What do you do? What? Plug some numbers in. What's an easy number between these two? What's the easiest number to plug in between those two? 0. Let's plug in 0. When you plug in 0, what do you get out? When you plug in 0 into that, what do you get out? 4. Okay, what's a number to the right of 2 root 3 over 3? Definitely to the right. What number can you say is definitely to the right of 2 root 3 over 3? What? Well, let's make it even easier than that. Make it bigger. How about 10? Is 10 definitely bigger than that? Let's plug in 10. When you plug in 10, 4 minus 3 times 10 squared, is that going to be positive or negative? It's going to be negative. You don't really care what the number is. You want to know if it's positive or negative. What happens when you plug in negative 10? It's the same thing. It's going to be negative again. So now what do we know? Where is it positive? 2 root 3 over 3 and negative 2 root 3 over 3. Can x be equal to 0? Yeah, it can. Why? Is it okay if 4 minus 3x squared, is it okay if that's 0? Yeah, what's the square root of 0? That's fine, right? So is it okay can they be equal to? So this right here is the domain. Because when x is between those two values or equal to those two values, the radicand is either positive or 0. It's either positive or 0. Another way to write this, just so you know, you can also write this like this. How many people have seen something like that before? Absolute value for ranges like that, for interval notation? Yeah, a little bit. What does this mean? What's the distance? What's the maximum distance if I have a point? So I want points on that interval, the green interval in the middle. What's the maximum distance you can be away from the origin and still be on the green? Exactly. What does absolute value mean? Distance from 0. So what's the maximum distance from 0 x can be? 2 root 3 over 3. Can you go either direction? Yeah. So this right here is the same as that. Just to give you a preview of kind of an easier way to write it. Why do you think that this is more commonly written than this? It's a really simple reason. It's less strokes to write. Sometimes when you deal with, we're going to deal with something called logarithms, and this are going to be used a whole lot, and in some books they're going to use one more than the other. Why do you think they use ln more than logs sometimes? It's 2 letters as opposed to 3. That's what I believe. Anyway. Okay, put everything away except a pencil. Okay, we covered that. Your homework, I'm just going to explain it now just so I don't forget it later. Your homework is going to be to design an original Unit 1 test. Here's what I wrote down for the other class. I might as well just copy it because it'll be a lot quicker. What does that mean? It means this. Well, let's see how that copies. Here it is. So, first part is you're going to get some work back in a little bit. You're going to work on corrections. The sooner you hand them in, the better. And you're going to write an original Unit 1 test. Your questions are on 1 sheet of paper, or 2 or 3. Answers are on another sheet. So you have to solve each of the questions. At least 2 questions for each topic from Unit 1. There's 5 topics from Unit 1. You could decide maybe something like 1 easy and 1 hard, but don't make it impossible. Make it fair something that you think would be adequate difficulty level. So don't make it too easy, because then we're not going to use them too hard, and you might get them. Please be specific and make sure there are questions in your questions. You can't just write an equation and expect someone to know what to do with it. So ask them, what is the domain of this function? What is the range of this function? Find, graph this. Make it a complete sentence. Make sure it's neat. And also make sure you write the answers. It's not just the questions, it's answers on a separate sheet. You can use books, notes for inspiration. You can use stuff from the net if you'd like. That's fine. I would prefer you write your own and modify questions that you find, but if you find a question that's really good that you think everybody should take a look at, use it. That's fine. Please keep in mind that someone else in the class is going to be doing all of your questions, so not just me. I won't be the only one looking at it. Someone else in this class. So if you hand in something that's really disgusting, someone else in this class is going to look at it, and they'll tell you about how much they don't like it, in addition to me. So not only are you presenting something to me, you're presenting something to your peers. Tomorrow we're going to do them in class, and then what I usually do is I then collect them all. I collect everybody's. I then cut out the ones that I think are the best questions, scan them, and then put them online for you guys to work on a study material over the weekend. So you'll do somebody else's test, and then I'll pick the best ones, and you'll have even more to work from. Because you're only going to do someone else's, then you'll have access to the best of everybody's. Does that make sense? Okay, what I'd like you to do right now is start working on your original test. So take out a sheet of paper, and you're going to start working on that right now.